Imagine if the ocean contained invisible walls more powerful than any barriers humans have ever built, boundaries that determine where every marine creature can live, hunt, and survive, creating underwater borders that have shaped ocean life for millions of years. Welcome back to Beneath the Depths. Today we're exploring one of oceanography's most fascinating discoveries, the invisible walls that divide our oceans into distinct zones, controlling marine life with an iron grip that most people never realize exists. These aren't physical barriers you can see or touch. They're invisible boundaries created by differences in temperature, salinity, chemistry, and pressure that act like impenetrable walls for marine organisms. Scientists call them thermoclines, haloclines, and chemoclines, but their effects are so dramatic they might as well be made of concrete and steel. The most powerful of these invisible walls is the thermocline, a layer where ocean temperature drops rapidly with depth. This thermal barrier can be so sharp that water temperature changes by 20 degrees Fahrenheit in just a few feet of depth, creating an invisible ceiling that many marine species simply cannot cross. Here's what makes these thermal barriers so extraordinary. They're constantly moving and changing, like invisible curtains being drawn and redrawn across the ocean. Seasonal changes, weather patterns, and ocean currents can shift these boundaries by hundreds of feet, forcing entire ecosystems to migrate or adapt to survive. The scale of these invisible walls is absolutely mind-blowing. In tropical oceans, the main thermocline can extend for thousands of miles, creating a massive underwater barrier that separates warm surface waters from the cold depths below. Marine life above and below this boundary might as well be living on different planets. But that's not the most amazing part. These invisible walls create distinct ocean neighborhoods with completely different communities of marine life. The warm surface waters above the thermocline teem with tropical fish, coral reefs, and surface-dwelling organisms, while the cold depths below host entirely different species adapted to low temperatures and high pressure. Scientists studying these boundaries have discovered that many marine species spend their entire lives without ever crossing certain invisible walls. Fish that live above the thermocline may never venture into the cold depths below, while deep-sea creatures are trapped in their frigid world by the warm barrier above them. The chemistry in invisible walls are equally fascinating. Differences in oxygen levels, acidity, and nutrient concentrations create chemical boundaries that are just as effective as physical barriers. The oxygen minimum zones in many oceans create dead zones where most marine life simply cannot survive, forming invisible walls of suffocation. Recent research using advanced underwater sensors has revealed that these invisible walls have incredibly sharp boundaries. In some locations, the transition from oxygen-rich to oxygen-poor water happens in just a few inches, creating knife-edge barriers that determine life and death for marine organisms. Here's where it gets really interesting. These invisible walls are constantly battling each other. Warm surface currents try to push down through thermal barriers, while cold, deep currents attempt to rise upward. The boundaries between these water masses create some of the most dynamic and productive marine environments on Earth. The Gulf Stream provides a perfect example of how invisible walls shape marine ecosystems. This massive current creates a moving thermal boundary that carries warm tropical water northward, bringing Caribbean marine life into temperate waters while creating barriers that prevent cold water species from moving south. Deep ocean trenches create some of the most dramatic invisible walls on our planet. The pressure barriers in these environments are so extreme that organisms adapted to surface pressures would be instantly crushed if they tried to cross into the deep, while deep-sea creatures would literally explode if brought to the surface. But that's not the most amazing part. Climate change is moving these invisible walls in ways that are reshaping marine ecosystems across the globe. As ocean temperatures rise, thermal barriers are shifting toward the poles, forcing marine species to migrate or face extinction as their invisible boundaries move away from them. The truth is even more incredible when you consider how these barriers affect ocean mixing and global climate. The invisible walls that separate different water masses control how heat, nutrients, and gases move through the oceans, directly influencing weather patterns and climate systems worldwide. Advanced computer modeling has revealed that these invisible boundaries are far more complex than scientists previously realized. Multiple layers of thermal, chemical, and density barriers can exist simultaneously, creating three-dimensional mazes that channel marine life into specific paths and habitats. Some of the most important invisible walls exist at the boundaries between different ocean basins. The waters of the Atlantic, Pacific, and Indian Oceans each have distinct characteristics, and the invisible barriers where they meet create unique mixing zones that support specialized marine communities. Recent discoveries have shown that marine animals have evolved incredible abilities to detect and navigate these invisible walls. Some fish can sense temperature changes of less than 1 degree, while others can detect minute changes in water chemistry that signal the presence of invisible boundaries. The seasonal movement of these invisible walls drives some of the greatest migrations in the animal kingdom. Whales, tuna, and other marine species follow the shifting thermal boundaries as they move with changing seasons, essentially chasing their invisible habitat walls across thousands of miles of ocean. Commercial fishing industries have learned to exploit these invisible walls, positioning their operations at the boundaries where different water masses meet. These areas often concentrate marine life and nutrients, creating productive fishing grounds at the edges of invisible barriers. The conservation implications are enormous. Protecting marine ecosystems requires understanding where these invisible walls exist and how they're changing. Marine protected areas that don't account for invisible boundaries may fail to protect the species they're designed to preserve. These invisible walls that control all marine life remind us that the ocean isn't just one massive body of water, but a complex three-dimensional landscape of invisible barriers that determine where every creature can live and thrive. The fact that these invisible boundaries have such enormous power over marine ecosystems shows us how much we still don't understand about our oceans, and how the most important environmental factors are often the ones we cannot see. What other invisible forces do you think might be shaping life in our oceans without us realizing it? Share your thoughts in the comments, and don't forget to subscribe for more incredible discoveries about the hidden structures that control our underwater world.